the UK government is contemplating introducing a minimum price for alcohol to reduce binge drinking and the consumption of alcohol in general. Suppose the following diagram shows the alcohol market in the UK. So it seems the diagram is missing here. In that case, we need to draw it. I have, for some reason, I forgot to include this diagram. So there is the diagram with quantities and prices, supply and demand, right? The current price of alcohol is 23 pence. So let's sketch that. 23 pence per unit, and units of alcohol are consumed each week. 8 units of. So next, what happens in the market if the government sets a minimum price of 30 pence per unit of alcohol? So, well, that's a little higher, isn't it, than the given price? So let's put this here, 30. Then the quantities will be different from equilibrium, obviously. So will there be an excess supply or an excess demand? Now, as you can see here, we have low demand. Quantity demanded is lower than the quantity supplied at this high price. So this is the price floor, basically. Price floor. This is price that retailers must charge, no less than this price. So that's the price floor as a result. And that situation creates in the market excess supply because we have more supply. So quantity supplied is greater here than quantity demanded here. Yeah, that's yes. Yeah. So this is an excess supply. 11. The demand for ice cream. So let's write down the demand equation. Quantity demanded is equal to 70 minus 4p, which is this, and the supply quantity supplied is 10 plus 2p, where p is the price of ice cream. Find the equilibrium price and quantity. Now, if you remember, in equilibrium we have supply and demand. In equilibrium, quantity demanded equals quantity supplied. Yeah? At this point, this is the point where demand and supply crosses, and we have quantity demanded and quantity supplied equal. So quantity supplied equals quantity demanded here. So using that identity or equality, not identity, so equality. So what we do, we just set the equations or equate the equations here. Right. So we will now take away 2p from both sides, or in other words, we gather the sort of unknowns and constants. Yep, we'll put them together. So this in that case goes to this side of the equation, that comes to this side of the equation. So then this will be minus 4p minus 2p equals 10 minus 70. Right, so okay, let me give myself some space here. Right, so that gives us 6p equals 60 with a negative minus sign, so that's going to be 60 over 6. These cancel out, negative signs, and we have 10. So that's 10 here. 10, let's say pounds. Yeah, 10 pounds. How about the quantity of ice creams at that price? So now we have price, equilibrium price. So we can use either a supply equation, demand equation, or supply equation. It will give us the same answer because at that price, the quantity demanded is equal to quantity supplied 4 times. So I'm using this equation here, but I could also use this if I wanted. Yeah, doesn't matter. So times the price 40, that gives us 70 minus 40. That's 30. So that is equal to 30. So that's quantity supplied and quantity demanded. Next, suppose consumers' income increases and ice cream is considered as a normal good. As a result, the demand curve for ice cream becomes this. Find the equilibrium price and quantity of ice cream. This is an interesting one. So let's put this together nicely here now. So this is price, this is quantity. By the way, we may need some space. Now, original demand curve. Let me write down the original demand curve somewhere here. Okay, that's 4p. 4p. So this is what we call, let's say, old demand curve, and new demand curve is now quantity demanded equals 100 minus that's 4p. Yeah, 4p. Right, so what's happening here? So let's have a look. So the only difference between these two equations is this intercept term here. So nothing, no slope, yeah, changing. So it's the intercept. So if we were to draw this, let me sketch this. So let's say this is the original point here, this 70. Then this would look like our old demand curve. Yeah, this would be our old demand curve. Let's get another color. A new demand curve would cross now at the point, let's say, where it is 100. So it will be exactly this parallel line. The reason is because the slope of the new and old are the same, yeah, slopes, and the old supply will remain the same, yeah, old. Let me just get that as well. So that's 10 plus 2p here. So supply is, so this was demand, supply is now quantity supplied equal 10 minus 2p. Yeah, let me just double check. Plus, sorry, why did I put minus? Minus is usually for demand, yeah. So the reason for plus is that it's upward sloping, isn't it? So let's say this is 10 here. So the supply curve is always upward sloping. So sloping upwards, supply curve, demand new and demand old. Right, so what do we have here? So original quantity at the equilibrium point was 10 what's this, 10 pounds, I guess we said 10 pounds, yeah. So quantity wise it was, what was it, 30, so that's 30. Now next, that is the next quantity. So suppose the consumer's income increase and ice cream is considered normal goods. When income increases, what happens is that if the product that you are consuming is normal, or normal good I should say, then you will consume more of it, yeah. So there is a positive income elasticity for normal goods, so there is a shift in the demand curve. As a result, the demand curve, okay, find the new equilibrium. So we just need to do this. We just need to equate the new demand curve, new demand quantity with old supply, yeah, or the supply. That didn't change basically. So it had that slope, it had this old, so nothing changed, in other words, yeah. So suppliers are still supplying. There's a shift in demand curve, but there's still suppliers are still supplying the same amount. So this leads to obviously higher prices. Let's move on, and we will equate the quantity demanded. So this is new quantity demanded equals quantity supplied. Then the solution is the same as before, then, yeah, the solution procedure. Again, we will take, basically we will gather the similar terms. So 2p goes to this side and gives us 2p minus 4p, and that quantity will come to the other side, to the right hand side, and this will be 6p equaling 90, and that's going to give us 90 over 6, which is basically 1, 5. So that's 1/5 price is £15 now. £15. Next quantity now. What do we need to do here? We will just have to get this P, the new price, into either of these equations. So I'll just pick the supply equation this time. Moving down here a little bit, have to clear the space later. Quantity supplied is then 10 plus 2 times 15, so that's basically 30, 40. So the new equilibrium quantity is 40. So that's the solution. Yeah. So new equilibrium price is 15 and quantity is 40. The next question here. Consider Sophia's and Marcus's total expenditure on sandwiches, and these are the prices given. The price, this is the first month, this is the second month. Yeah, so there is a price increase from $4 to $5, and this is then Sophia's spending. So use the midpoint formula to calculate the price elasticity of demand for Sophia when the price of sandwiches increases from. Okay, so for the midpoint method, let me write it down first. Maybe here. Let's write it down so that's visible to us. It's the percentage of percentage change in quantity demanded over percentage change in price. That will be quantity 2 minus quantity 1 over quantity 2 plus quantity 1 over 2 over price 2 minus price 1 over price 2 plus price 1 over 2. So this would be the formula we'll be using, but we need now quantities. We know the prices are given here, but then so we don't know the quantities. So for Sophia's quantity 1 first month is basically 80 over 4, so $80 over $4 gives us the quantity of sandwiches that Sophia bought at $4, so that is 20 units. Quantity 2, the same applies here, $90 over now $5 per sandwich, so that gives us 1, so what's there for 18 units of sandwich. Yeah, right. So now we have the quantities, we can now plug them into the elasticity formula. So we'll start with quantity 2. So quantity 2 is this month, the last month, which is now in this case 18. So 18 minus 20 from here over 18 plus 20 over 2 over what's this price now? Prices are new price minus the old price over new price plus the old price over 2. That gives us minus 2. In here we have 36, which is then divided by 38 divided by 2 is 19. And here we have 1 over, what's this? This is an very cumbersome number, I should say, which then gives us something like, what's this here? Minus 2 over 19. The denominator ratio here, this, let me just draw, probably you don't see my cursor here. So this thing here, this whole ratio will basically flip and gives us something like 4.5, yeah, something like that. So that's gonna be roughly 0.47 here. So this is inelastic demand, yeah. So Sophia has an inelastic demand for sandwiches. So moving on now to the next one. Use the midpoint formula to calculate the price elasticity of demand for Marcus when the price of sandwiches increases from 4 to 5. So now it's exactly the same thing repeated for Marcus. Now all we need to do now is just work out the quantities and work out this price elasticity. So we have the formula above. So what's the quantity 1 for Marcus? It's basically he spent $60 on $4 I should say sandwiches, so that gives us 15 units. Quantity 2, second month quantity demanded is now $50 spending, and when price was 5, so that's 10 units. Now oops, we need space here. I now have the quantity, so all I need to do is not plug them in. So 10 minus 15 over 10 plus 15 over 2. What we have here is 5 minus 4, 4 plus, sorry, this is 5 plus 4 for consistency over 2. Now that will be, if you do the math, something like this, yeah. So that is an elastic demand. So Marcus has an elastic demand here, while Sophia has an inelastic demand for sandwiches. So next now, with your answers to A and B, explain why Sophia would spend more on sandwiches while Marcus spends less when the price of sandwiches increase. We'll start with Sophia. Her price elasticity of demand was minus 0.47 if I remember correctly. So this is less than 1 in absolute terms. Sophia has an inelastic demand for sandwich, which means when price increases, Sophia will still buy extra sandwiches. Yeah, Sophia's demand will not disappear or doesn't decline faster. Yeah. As we could expect, yeah, because she treats these products as kind of necessities. She needs them. She keeps consuming them. In this case, when the price elasticity is lower than 1, the increase in price will be greater than the decline in percentage decline in quantity. So let me show you what I mean here. So this is an kind of inelastic demand, yeah, here. So let's say this is original point here with the 20 sandwiches, and this was what, 4, yeah. So $4 and 20 units, yeah. But then price went up to, let's say, 5 here, $5, which is the price given to us. Notice what happened here. Quantity declined only, small amount, by a small amount. This is a small decline compared to this rise, yeah. So because price rise by a higher percentage point than the decline in quantity demanded, expenditure increases, yeah. So she will still spend more, yeah, as a result, because the percentage increase in price is higher than this percentage decline in quantity. So that's the reason. Next is about Marcus. So let me just give myself a little space here. Marcus has a price elasticity greater than 1, basically. So that's greater than 1 in this case. What was it? So that's an elastic. So 1.8. So Marcus's price elasticity is 1.8 with a negative sign. So we should draw it again. Now this is an elastic demand, so a little flatter here. Flat demand, right? So notice here, this is our, let's say, this is our old curve, this is our new, this is our, sorry, not old curve, points. So this is, what's this, 4, this is 5, this is a quantity. This was, if I remember, was it 20? No, I must be taking Sophia's quantities. Yeah, 10 and 15. So this is 15, this is 10. When the price went up, this is the sort of change, or this is a small change, yeah, compared to the quantity demanded. So quantity demanded declined by a greater, as a result, percentage point than the price increase here. So that reduced basically total expenditure by Marcus on sandwiches. So this is original area under the curve, which gives us the total expenditure. After the price changes, then we get this area as a total expenditure. So what we lost is this whole area, so a big amount of loss in this case. So this is basically reduction in expenditure, and this is increase in expenditures. So the increase in expenditure, actually additional expenditure, is this area, but this is a small area increase compared to the decrease in expenditure. Yeah? So, well, with an elastic demand, we will have lower total expenditure when the prices increase. But with inelastic demand, we will have higher expenditure when the prices increase. Now, you can assume that Marcus basically quickly switched to a substitute product when the price increased, while Sophia didn't. She reduced her consumption, but she didn't substitute the product with another one. Next question. When Sven graduated from college and got a job, his income rose from that to that. His consumption habits also changed drastically. Use the following information to determine his income elasticity of demand and state whether the good is normal, inferior, luxury. Use the midpoint rule in your calculations. Okay. Ramen noodles. So consumption falls from 7 packs to 0 when they are up. That's a huge jump, isn't it, in income? So he's got a very good job. Right, so let's start now. Income elasticity is equal to percentage change in quantity demanded over percentage change in income, basically. Right, this is a midpoint method, so a little space consuming formula. That will be our formula. So let's calculate now. All we need to do is just plug in the numbers. Quantities. So we have quantity 2 after the income change is 0. Quantity 1, 7 packs. The income 1, okay, we need space here. We need that space, so let's put this here. Income 2 is 60k. Income 1 is 15k. So let me put this here, k. Right, so quantity is 0 minus 7 over 0 plus 7 over 2. Or income's now 50, no, this is now 60. 60 minus 15 over, what's this, 60 plus 15 over 2. So I need a calculator here. Right, so income elasticity in this case is negative, so which certainly means that the noodles are inferior goods. Sven started consuming less of this product because of his income increasing, so that's an inferior good. Now certainly this is a big increase, yeah, so quantity demanded of necties. So the first quantity is 1, second quantity is 11. So we know the income change. We know the income change from before, so that's, we don't have to calculate. So all we need to do is just calculate the percentage change in percentage change in quantities here. So income changed, but we need to calculate the quantity demanded change for the necties. Yeah, that will be quantity 2 minus quantity 1 over quantity 2 plus quantity 1 over 2. Yeah, that's a positive value. So when we do the income elasticity, we should get a positive value too. So that's greater than 1. So income elasticity greater than 1 is usually a luxury good. Luxury good. Next, it's burrito. It's a positive value here. So quantity 1 for burritos is 1, quantity 2 for burritos is 2. Now percentage change in quantity again. We have 2 minus 1 over 1 plus 2 over 2, which gives us 1 over, what's this here, 1.5, which is something like this down. It's easy. Now again we have the quantities change in quantity and income change here. Right, so that gives us around 0.56. This is certainly greater than 0, which makes this product a normal good. But obviously this is less than 0, less than 1, so that's a normal good. Next question. So suppose that the income elasticity of demand for potatoes is negative 0.5. That's income elasticity for potatoes minus 0.5. And the cross price elasticity of demand for potatoes with respect to the price of carrots is 2. So cross price elasticity between carrot and potatoes, let's put this down. So that's percentage change in quantity demanded for potatoes over percentage change in price of carrots. Yeah, so carrots, this is C, is 2. Right, so let me just give myself some space again. This means basically potato, so this is negative, yeah, so negative sign here implies potatoes are inferior good. So which means when our income increases we consume less potatoes. If our income goes down we consume more potatoes. Yeah. Now this here positive elasticity value, cross price elasticity value. So this means basically when the price of carrots increase, quantity demanded for potatoes increase. So that's substitute products. Yeah, these two are substitutes. Right now, so let's answer the question now. What will happen to the quantity demanded for potatoes when there is a recession? Well, in recession, usually we have incomes, lower incomes. That means the quantity demanded for potatoes increase because they are inferior goods. Yeah. Right. Moving down here. Next question: when the price of carrots decreases? So when the price of carrots decrease, carrots are cheaper than potatoes, so quantity demanded for potatoes increase. So that's the answer. Next question here. So when there is a recession and the price of carrots decrease, what happens to quantity demanded of potatoes? Yeah. In that case, so we have two cases here, two effects. First is the recession effect. So in the recession, incomes go down. That leads to, because potatoes are inferior goods, that results in quantity demanded for potatoes to increase. Yeah, that's P. Second effect is the price of carrots decreasing. So when the price of carrots decrease, since potatoes and carrots are substitutes, quantity demanded of potatoes will decrease because cheaper carrot means people tend to buy more carrots. Now, these are two countervailing forces here, right? So one induces the quantity demanded for potato increasing. The second one induces decrease in the quantity demanded for potatoes. Now, the net effect, whether quantity demand increase decrease, depends on which one of the two is stronger. Yeah, which of the two effects is stronger. If income effect is stronger, then we would expect the net effect to be higher quantity demanded for potatoes. If, however, the price effect is stronger, the price is so low it's even lower than, let's say, than normally expected, then we would expect the quantity demanded for potatoes to go down, because the people will buy more carrots as a result. So in that case, this force will, the decline, there will be the decrease in the quantity demanded for potatoes. Yeah, so it depends on these two effects, whichever coming stronger. The next question. Nadia consumes two goods, food and clothing. The price of food is $2, the price of clothing is $5, and her income is always $1,000. Nadia always spends 40% of her income on food, regardless of the price of food, the price of clothing, or her income. Okay, so what is her price elasticity of demand for food? We'll calculate the quantity demanded using the prices, yeah? So given that Nadia spends 40% of her income, so expenditure on food is basically 0.4 times 1,000, which is $400, right? So that's my dollar sign. And quantity demanded at $2 per food is then 400 over 2, which is 200, let's say, units, whatever the units are for food. Next, let's now assume to see what her price elasticity of demand for food is. We'll assume that the price 1 is $2 as given. Price 2, which is an increase, let's increase the price to $4. Yeah, so that is twice the price, original price. Yeah, the quantity demanded, let's put 1 here, is 200 units. Then what's the quantity demanded to after the increase in price? So that's 100. So let's use midpoint method. So is 100 minus 200, quantity 1, over the average of the 2, plus 200 over 2 over the price. So that's 2. So this is 4 now, P2 minus P1 over 4 plus 2 over 2, and it's 1, exactly 1. Yeah, so this is a unitary elastic demand. So next question now. What is her cross price elasticity of demand for food with respect to the price of clothing? Now notice this, holding everything else constant, a cross price elasticity of demand for food with respect to clothing is percentage change in quantity demanded for food over percentage change in the price of clothing. What we know is that when the price of clothing changes, this numerator doesn't change. So you can come here and read this. It says Nadia always spends 40% of her income on food, regardless of the price of food, the price of clothing, and her income. So price of clothing, regardless of the price of clothing, she's spending exactly the same amount. And we know that when the price of clothing changed, we are still holding the price of food constant, which means then percentage change in quantity demanded of food is 0 here. No matter what comes here, it's always 0. Yeah, 0 divided by whatever in the denominator is basically 0. Yeah, so the answer is 0. Next question. What is her income elasticity of demand for food? Now let's read this again. So it says Nadia always spends 40% of her income on food, regardless of the price of her income, regardless of her income. Now we need to come up with this hypothetical example again. Let's calculate that her current income 1, is $1,000, and income 2 is, let's say, double, and we hold price of food to be equal to $2 either case, yeah, whether there is an increase or not in income. So let's now calculate the expenditure in that case on food. Let me just get this off. Yeah, right. So expenditure 1 is equal to $400 as before, which leads to the quantity demanded of food 200 units as before, expenditure 2 after the increase in the income, so her income doubled, that would be to $2,000, and she's spending roughly 40% as it says in the text of the question, so that's going to give us $800 of expenditure. The quantity demanded 2 now, second period quantity demanded after the increase in income is now different, obviously, holding the price of food constant, so 800, put this nicely, and this is 2 still, yeah, so the food price didn't change, and that gives us 400, so that's a doubling, isn't it? Income elasticity of demand is equal to quantity demanded. Where is the quantity demanded? So that's number 2 is 400 minus 200 over 400 plus 200 over 2. Now the income 200, 2000 in this case, 1000 over 2000 plus 1000, 2. That's equal to, so that's giving us 200 here on the numerator, on the denominator 300, there it's 1000 over, what is this, 1500, and let's put them in a easy to calculate form, so that flips. Now what we have here, this goes, this is 5, and this is 5 too, so 5 over 5 is equal to 1, so the income elasticity equal to 1.